in solving simultaneous equation, you get one method that they call Cramer's rule. That Cramer's rule is very, very important because it is easy to apply when you want to solve simultaneous equation. Look at this simultaneous equation we will get here. We'll just say this one is equation 1 and this one is equation what? 2. We don't get these two equations. I want to solve to get the values of x and y. You understand? Using what? Cramer's rule. So how would they do it? First of all, we need to understand, say, we have coefficient of x here being 4. We have coefficient of y here being 2. We have coefficient of x here. You know, here now, just x, that is 1x. So we have an invisible 1 here, and we have 2 as coefficient of y. So in that case, we can get a 2 by 2 matrix. We can get a 2 by 2 matrix using the coefficients of these what? Unknown we won't look for. So here we get 4, here we get 1, here we get 2, and here we get what? 2 also. So that means to say that we don't get a kind of matrix. Let's call it matrix A. So the next thing is to get the determinant of this matrix A. We get the determinant of this matrix A. This determinant will be this times this minus this times this. So 4 times 2 will give us 8. Minus 1 times 2 will give us 2. So 8 minus 2 give us 6. So the determinant of this matrix now what? Now 6. This is not actually the answer for now. The answer will now be from getting another kind of special matrix where we will get when we replace 10 and 7. That is the solution values for here. 10 and 7 will by with what? With each of the coefficients here by trying to get x and y. So move down together, make it see as the thing is simple. From this place, we don't get this matrix. Now we'll get another special kind of matrix. We want to solve for x. Okay, let's say we get a special kind of matrix. Let's say this x matrix equal to, remember what we do for here from the coefficient of this where we got 4, 2, 1, 2. Now in this case, this 4 and 1, remember saying our coefficient of x now we get them from. But we won't calculate for x. We don't go just use this coefficient of x again. We go use the solution value I told her before. Use and replace this coefficient of x in this place. So this solution value is now 10 and 7. So instead of getting 4 and 1 here, we just replace them with what? With 10 and what? And 7. Whereas if we just get the determinant, 10 times 2 minus 7 times 2. 10 times 2 now what? 20. 20 minus what? 7 times 2 now what? 14. So the determinant is what? Will give us 20 minus 14 will give us 6. The determinant of this special matrix for x, determinant of this special matrix for x don't give us what? 6. This is not actually the end though. I will show you how would they get the actual values of x and y. So we will get another special kind of matrix for y. Another special kind of matrix for y and to get the determinant. Another special kind of matrix for y and to get the determinant. So this is a special kind of matrix where these coefficients now, just like we did here, we replaced 10 and 7 with 4 and 1. So here we will bring back 4 and 1 because now y we won't work with now. Instead of writing 2 and 2, what we got from the coefficient of y, we will still replace them with this 10 and 7. So we'll get 10 and 7 here. We'll get 10 and 7 here. And getting this 10 and 7, the next thing is to just get the determinant. The determinant of this one will be this times this minus this times this. That is 4 times 7. You understand? Minus 1 times 10. 4 times 7 now what? 28. Minus 1 times 10 now what? 10. So 28 minus 10 will give us what? 18. 28 minus 10 will give you 18. Now let us now solve. Let us now solve y determinants. Now be this how we will actually do. So we will just now solve for what? Our x and what? Y. So to get x, x will give you what? This is how we take get x using the Cramer's rule. Now to get x, we just need to just do this determinant over the original determinant. That is this x determinant over the original determinant. So we have x determinant over what? The original determinant. We will give you x determinant. We got them as what? As 6. 6 over what? The original determinant now what? 6. So our x is equal to what? 1. Our x don't be equal to 1. The same way for y, to get to our y, We'll look for y determinant. That is the determinant of the special matrix for y. Y determinant now what? 18. Y determinant over what? The original determinant, which is what? 18 over what? The original determinant now 6. So 18 over 6 will give us 3. So in that case, x now 1 and y now 3. So this is how we apply the Cramer rule to solve some sets of simultaneous equations. God bless you as you listen to this point.